So hello guys, this is another question from IIT JEE PYQ. The question is from the chapter friction, work power energy here. Okay. Here is the question: a light inextensible string that goes over a smooth pulley, as shown in the figure, connecting the two blocks. One is of 0.36 kg and another is 0.72. So here I am taking this m and this is our 2m. Okay. And we have to take g is equal to 10 meter per second square here. Find the work done by the string on the block 0.36 kg, that means m, during the first second of its after the system is released from the rest. Okay. So here first I will find the acceleration of the system, that this block will be going downward with an acceleration a, and this block will be going in upward direction with an acceleration a. Okay. So from the Newton laws of motion, I can directly write this acceleration will be equal to net pulling force divided by total mass. So net pulling force means what? 2 mg minus this mg. This is the net pulling force divided by total mass is what? 2m plus m. Okay. So this will be equal to what? mg divided by 3m. M will be cancelled out and this will be equal to g by 3. Okay. So acceleration of the system we are getting here, that is equal to g by 3. Okay, that is meter per second square. Okay, so we will substitute the value of g later. Now let me draw the free body diagram of this small m here. This is our small m, and one force is acting on this small m in the upward direction, that is tension in the string, and one force in acting in the downward direction, that is what? Weight of this body, mg, right? And this block is moving in the upward direction with an acceleration a is equal to g by 3 meter per second square. Now I have to write the equation of motion for this block. So equation of motion, F net will be equal to mass into acceleration. Since it is moving in the upward direction, then I will write the equation of motion T minus mg, that is equal to m into acceleration. Acceleration is what? Mg by 3. Okay, so from here I can easily find out what is the value of tension, that is what? Mg plus mg by 3, that means 4 mg by 3. Okay, so this is the 4 mg by 3 Newton is the tension in the string, and we have to find out the work done by this string, that means work done by this tension force on this block of mass m in the first second after the system is released from the rest. Okay, so when this system is released from the rest, then initial velocity of this block of mass m is what? 0. Okay, and it is moving in the upward direction with an acceleration a is equal to g by 3. Okay, so at t is equal to 0, it is here. Let us pause at t is equal to 1 second. In the first second we have to calculate during the first second. Okay, so at t is equal to 1 second we have to calculate what is the displacement of this body m has traveled. Okay, so we can use the equation of motion here, that s is equal to ut plus half at square, ut plus half at square. Okay, so s will be equal to this u is 0, so this term will be 0 plus half into the value of acceleration is g by 3 in the upward direction, so g by 3, and the value of time is 1, so it will be 1 square. So the value of this s we are getting here, that is equal to g by 6 meter. Okay, now work done by this tension force on this block m, that I can write here. This is our block m. Okay, and tension force is acting in this direction, upward direction on this block, that is T. Okay, and displacement of this block is also in this direction, that is S. Okay, so work done by this tension force is W, I will write here, dot product of that force and displacement, that is F vector dot S vector. This will be equal to F vector is what? T vector, that is T, and the displacement is S, and the angle between them is what? 0 degree, so cos 0 degree. Okay, so this will be equal to T dot S, right? So here I have to substitute the values of tension and this displacement, then work done will be equal to, the value of tension is 4 mg by 3 as we have calculated earlier, so 4 mg by 3 multiply by the displacement of the particle is g by 6. Okay, Now I can substitute all the values here. The value of m is what? 0.36 kg. So 4 multiply 0.36 kg multiply g square will be what? 10 into 10 divided by 3 multiply 6. Okay, so this point will be cancelled out from this tan square, and we can cancel all these terms here. 3, that will be 12 here, and 6, this will be 2. Okay, so here we will be getting that work done will be equal to 8 joules. Okay, so work done by the string on this block of mass m is what? 8 joules. So this is our answer for this question. W is equal to 8 joule. Okay.